What happens when atoms combine? When atoms combine, they form compounds. Compounds can be classified as either ionic or covalent. Let's have ionic compound. Ionic compound results from the attraction between a cation and an ion. An ionic compound assumes a crystalline structure, a three-dimensional well-ordered arrangement of cations and anions. Generally, examples of ionic compounds are the different types of salts. In this topic, you will also learn how to write and name chemical formulas. All you have to do is apply the concept of naming, which you have learned earlier. And of course, applying the rules of writing correct formulas, which I will be discussing. This time, I'll be discussing the rules in writing correct chemical formulas. Number one rule is write the chemical symbol for cation first, followed by the anion. Example, Na positive 1 and chlorine negative 1. Na is the cation, so therefore, we should write Na first. And chlorine here is the negative ion or the anion, and it comes next. So, the correct chemical formula of the combining atoms Na positive 1 and Cl negative 1 is NaCl. What would be its name? Are we going to use classical or stock method of naming? Definitely not. Why? Because sodium is not one among the metals with different ions. So the naming is very simple. You just simply get the whole name of the cation followed by the root name of the negative ion and ends with IDE. Therefore, the correct chemical name of NaCl is sodium chloride. Let's have the second rule. Set the charge number of one ion as the subscript of the other ion. This is known as the crisscross rule. Subscript or subscripts are small numbers usually written after a chemical symbol or a chemical formula. Let's have an example. And the combining atoms are Fe positive 3 and S negative 2. The charge of Fe, which is positive 3, will become the subscript of S. And the charge of S, which is negative 2, will become the subscript of Fe. And there you go. We have now 2 and 3 aggregates. So the correct chemical formula of the combining atom Fe positive 3 and S negative 2 is Fe2S3. Next is, how are we going to name this chemical formula? Are we going to use classical or stock method of naming? Yes. Why? Because Fe is one among the elements or metal elements with more than one ion. Therefore, what would be its stock name? it's iron 3 sulfide. How about its classical name? Since Fe positive 3 is the ion of iron with higher charge, then therefore, we are going to use the suffix IC or -ite. So, the correct classical name of the compound would be ferric sulfide. Let's have the third rule. A subscript of 1 is not explicitly written in the formula. Note, if the element in the formula does not have a subscript, the value is understood to be 1. Let's have an example. The combining atoms are K positive 1 and I negative 1. Applying the rules, the crisscross rule, we have K1 and I1. But since we're not going to write 1 as the subscript, then therefore that formula is wrong. So, the correct formula would be Ki. How about its name? The correct name is potassium iodide. There is no classical or stock name of this compound since K or potassium is not one among the metals with more than 1 ions. The fourth rule. If the formula contains reducible subscript, then the subscripts are expressed in the simplest ratio. Example, the combining atoms are Sn positive 4 and S negative 2. Applying the crisscross rule, we get Sn2 S4. Is it reducible? Yes. It is divisible by 2. So, dividing for Sn subscript of 2 and 2, we get 1. And for S, we have 4 divided by 2, we have S, a subscript of S of 2. That would be wrong, and this one would be the correct chemical formula. The stock name is tin 4 sulfide. The fifth and final rule. For a polyatomic ion requiring a subscript other than 1, the ion is enclosed in a parenthesis before the subscript is affixed. Example, the combining ions are Ca positive 2 and PO4 negative 3. Crisscrossing their charges and written as subscript, we get a chemical formula Ca3 PO4 in a parenthesis and then a subscript of 2 followed. Can we apply reducing of the subscript? No. The subscript that can only be reduced are the ones coming from the crisscross charges and written as subscript, and not the subscript of the radicals or polyatomic ions. So never reduce the subscript of polyatomic ions. And what is the name of this compound? In naming compounds such this, we just simply get the whole name of positive ion and the whole name of the polyatomic ion. So the correct chemical name is calcium phosphate. Let's have another example. The combining ions are Cr positive 2 and P2O7 negative 4. Crisscrossing their charges and written as a subscript, we get a chemical formula Cr4 P2O7 enclosed in a parenthesis and a subscript of 2. Since 4 and 2 are reducible, and since divisible by 2, we get 4Cr. 4 divided by 2 is 2. So we have Cr2, and 2 divided by 2 is 1, and we get P2O7 enclosed in a parenthesis and a subscript of 1. But since 1 is explicitly not written any longer, then therefore the final formula is Cr2P2O7. The stock name of Cr2P2O7 is chromium 2 pyrophosphate. And the stock name is chromous pyrophosphate. Here are points to remember about naming a compound from its formula. Number 1. The order for names in a binary compound is first the cation, then the anion. Number 2. Use the name of cation directly from the periodic table. 3. The name of the anion will be made from the root of the element's name plus the suffix ide. Number 4. For ionic compound containing polyatomic ion, write the whole name of metal element followed by the name of a polyatomic ion. Some ionic compounds have water molecules incorporated in their structure and are called hydrated salts. A Greek prefix is added to the term hydrate to indicate the number of water molecules per formula unit of the salt. Example: copper sulfate with 5 molecules of water is named as copper 2 sulfate pentahydrate. Acids are compounds that can give off hydrogen ions when dissolved in water and become aqueous. They are easily recognized because their chemical formula begins with H. To name the binary acid in its aqueous form, the anion name is prefixed with hydro, suffixed with ic, and added the term acid. Examples: HCl, when it's added to water, and H2S, when added to water, the name is hydrochloric acid, which is in aqueous form. And for H2S, it is hydrosulfuric acid. A ternary acid forms from polyatomic ion. The acid name is based on the polyatomic ion. The suffix ite is replaced with ous and ate with ic. Examples: we have the pairs nitrite and nitrate. Once these ions are added to water, for nitrite, the acid formed is HNO2, called as nitrous acid. For nitrate, the acid formed is HNO3, which is nitric acid. We also have SO3 and SO4, sulfite and sulfate respectively. When added to water, they form an acid. For sulfite, the acid form is HSO3, which is sulfurous acid. And for sulfate, the acid form is H2SO4 or sulfuric acid. Covalent compounds results when nonmetals share electrons. Thus, covalent compound exists as molecules. Naming binary covalent compounds utilizes Greek prefixes to indicate the number of atoms of the element present in the chemical formula. The first element is prefixed and named in full. The second element is named using its first few syllables and suffixed with IDE. The letter A in a prefix is usually dropped when followed by a vowel, as in case the tetroxide and pentoxide. The prefix mono is seldom used on the first element in the formula. Listed on the table are Greek prefixes used to indicate number of atoms. Mono for 1, di for 2, tri for 3 atoms, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8 atoms, nona for 9, and deca for 10 atoms. Let's have examples. CO2 is named as carbon dioxide. We have prefix di for oxygen because there are 2 atoms in the chemical formula. N2O4 is named as dinitrogen tetraoxide or dinitrogen tetroxide. Some binary covalent compounds are not named systematically, but rather take trivial names. Water, H2O, and ammonia, NH3, are examples of these compounds. Can you name this? If you said carbon tetrachloride, then you're right. How about this one? Yes, carbon monoxide. How about that one? SF8. Any guess? If you said sulfur octafluoride, then you're correct.